Okay, now I want to draw an analogy between water and the series and the parallel circuits. So in a river, let's say that the river is up here, okay, then it's going to go over a waterfall. Okay, then it goes horizontal for some distance, and then it goes over a second waterfall. And then it continues over here. So this is our situation where you have a single river goes over a waterfall, then over another waterfall, and then it continues on like this. Okay, so that the flow rate, the rate at which the water is flowing in the river is going to be the same everywhere. The volume of water per second is going to be the same everywhere. Now, how do we know that? So let's say that the volume flow rate up here is 10. So it could be 10 gallons per second. It could be 10 cubic meters per second. It's 10. Now, what would happen if the flow rate here was a 9? It had a different flow rate right here. Well, what would happen? Well, more water would be pouring in than could be carried away. So that would mean that this would turn into a lake right here. Okay, that can't be. So whatever the flow rate is here, it has to be the same here, and it has to be the same here. What about if this was an 11? So instead of being a 9, it was an 11. What would happen? Now more water would be drained from this area than would be replenished by this up here, and so this would dry out. So you would no longer have a river located right here. So therefore the flow rate has to be the same everywhere. Okay, then what about the energy of the river? So the energy, if the river was just to drop straight down, it would have a certain amount of energy. But that would be the same as the energy of this drop plus the energy of that drop there. So that's the reason why the total voltage is the sum of the individual voltages. Pretty cool, huh? Yeah? All right. Now what about the parallel circuit? So now this was a sideways view. Let's look at the top-down view of a river. So here you've got a river, and it's going to come to an island. So here's an island right here. So now the river has a choice. The river could either flow this way around the island, or it could flow this way around the island. And so, depending on the depth of the channel on this side versus this side, it could have a different flow rate. So this is equivalent to the current. If you have a parallel circuit and it's got two different routes, it could have two different currents as it goes around it. What about the voltage? Well, see, it's at a certain height when the river is up here, and it has a certain height when it's down here, when it's below the island. But notice it's at the same difference going from this height to this height if you go this way as if you go this way over here. So this time it's going to be the voltage that would be the same everywhere in the circuit when it's a parallel circuit. Ooh, I'm just getting tingly from all this mathematics. I hope that you are too there. All right, let's take one more break. When we come back, let's talk about how did we arrive at the sum of the resistors formulas.